I'm just going to go through the selective test execution. So I think first of all, what it is. So the idea is that we want to run more targeted tests for backend and front-end code. So given the size of our code base, the hypothesis is that we don't necessarily have to run all the tests for every merge request, because many of the merge requests will probably just be changing like a couple of files, maybe a handful maximum. And given those, we should be able to identify tests that are directly related to those changes and only run those specifically. So with that, we hope to be able to get a faster pipeline so that we get faster feedback from that, from the less number of tests being run, as well as saving the cost, because then we have much less runner time being used. So how is it done? I'm just going to share my screen and then I'll go through. So hopefully you can see. So I'm using my iPad as a whiteboard, so we will see how that goes. So I think if we were to look at our code base, we have front-end code on one side. We have back-end code. So this is like JavaScript, and this is mostly Ruby. And from test perspective, we have just for the front end, and we have Aspect. So far previously what we've done was that every backend code will run almost all the Aspect tests, and then every front end changes will run almost every, it will run all the just tests that we have. So we want to be more selective in running only related just tests for front end code, as well as related Aspect code for backend. So then the question is, how do we link the two together? For the backend, we are using Crystal Ball. So Crystal Ball trades the code coverage of the test and the source code, and then with that, it will do a reverse map and identify what Aspect code needs to run for specific Ruby files. So what we are seeing with Crystal Ball is about, I think, 85% accuracy, meaning 85% of the time it will be able to cover 100% of the changes of, so 100%, it will be able to catch 100% of the test that needs to be run, so that we don't get into a master broken situation, or we get a regression where the test fails without us knowing. So the missing 15% can come from things like various ways of metaprogramming, which then doesn't get tracked in the code coverage. So we have done this so far. And then for front-end code, we are actually using Jest itself. So Jest has this thing called find related test, which has been pretty good. It's close to more than 95%, I would say, accuracy. I think it's even close to 100%, because what I've seen was that the failures that we found was actually master broken failures that also exist in the main branch. So it's not really because Jest was not able to identify the dependencies between the code and Jest. And yeah, so now we have these two. I think Jest, we are pretty much, we are running Jest with related tests for all front-end changes. So the challenge is now between the backend code and Jest. So we have this sort of dependency where now we still run all the Jest tests that we have for every backend changes, because there's the fixtures in the middle. So the fixtures are generated from backend and then it's loaded by Jest to run the test. So then we need, right now we don't really know how we can identify what Jest needs, which front-end test needs to run given a change in backend because of the fixtures. So there are like two parts to this. So first, so one part is linking between the Ruby code to fixtures. So we don't have this right now. And the other part is linking the fixtures to Jest. So this is right now in progress, like about maybe 80% done, I would say. We have been migrating the use of fixtures in Jest to use the import. So using import, then Jest will be able to identify specifically which fixture file is used in which test files. And because of that, then given a change in a fixture, we can then trace to specific test files that we need to run. So the missing piece will be then right now is this, which is how do we track Ruby to fixtures. I think we have ways, we probably can find ways to do it because of how the test is written. It's an aspect test which just generates JSON or HTML and save it into a file and given a specific file name. So we can probably trace that and then sort of use similar like crystal ball or something just to keep track of the coverage, like to use the coverage and link that to the backend fixture spec file. Yeah. So right now the missing part is really this. Yeah, I think So that's how I see the entire code and the test being dependent on each other, and where is the missing gaps that we need. Any questions so far? Oops. Okay, I didn't see the chat. 1 minute's up.
That's okay.
Yeah. No questions? Okay.
I would just ask one question just to clarify here.
Yeah.
The selective tests or like the find related tests in Crystal Ball, those run prior to approval, right?
Yes.
Okay.
Yeah. Yeah, I'm not gonna. I decided not to go through that here because I think most of us are aware about that, and I think the part that is not very clear is how all the pieces are fitting together, and I thought it's best to give that overview.
Sounds good.
Yeah. So yeah, I'll probably draw this up and then put it up in one of the issues. And the last thing I want to share is just the chart. So I'm not sure if everyone knows about this dashboard. Yep. Questions?
Given that our fixtures are also written in RSpec, so can we do the same? Use Crystal Ball? Okay, I guess that's the plan.
Yeah, I think that's one way. We might still need to run all of them, and I haven't really thought through in detail, but yeah, I think we can do that.
Okay, cool.
Yeah.
So the plan, if we can do that, like if we can from front-end fixture spec, find a RB file that would cause this to change.
Yeah.
Would the plan be to only regenerate the fixtures that are subject to change?
Yeah, I think we still need to regenerate all the fixtures because there might be other tests that are dependent on the front end code, and not the back end, but just the front end. But it still requires another fixture file that didn't change from the back end. Does that make sense? Like we might have two fixtures, A and B, for example, fixture A is not changed, but fixture B is changed by the backend. And then we have a test that requires both of these fixtures. And in that case, we still need to generate both of them, not just B.
Okay. And do we still plan to actually check in the fixtures in the repo?
I think it's not necessary to do that for this purpose. I think that can be a separate initiative, I would say. Like, yeah, it can be decoupled, because I think checking in the fixtures is a more complex process so far. I think it requires a lot more collaboration, more changes to developer workflow for the front-end engineers especially. So I think we should separate the two.
And just to add to that, I chatted with IP last week on that and treating it as a separate initiative. He kind of I was pointing out, we don't really have the front end workflow expertise to know how to do this without creating impacts to all front end engineers. And he also said, like, he had a really good suggestion of bringing a member of the EP team, 1 or 2 backend engineers, and then 1 or 2 front end engineers from foundations to come up with a solution for how we can manage fixtures in a more reproducible manner versus generating them every single time. So being more efficient there. It seems that because of developer workflow on both front end and back end, there's just more considerations than just let's commit them and let them go. There's a few more impacts that we need to identify and figure out how to mitigate. And I agree with Albert. It's going to be a separate initiative, maybe something that comes up in Q4. And we can talk about that related to OKRs down below too.